Hello everyone, I hope you are doing well wherever you are. This is your tutor, Mr. Mlenga. So welcome to my YouTube channel. As you can see, we are still on the calculus, lesson 2. So in lesson 1, we started looking at how we can differentiate functions using a formula, okay? So this lesson 2 is just a continuation of our lesson 1. All right, so our first question there is saying differentiate 3 plus 5x minus 2x raised to the power of 3. Okay, so how best can we answer this? Remember, in an exam, if they just ask you to say differentiate, you can use any method that you feel like to differentiate a particular function. Okay, now if they specify to say differentiate using the first principle, differentiate using the chain rule, differentiate using the product rule, the quotient rule, you have to use the rule that they have told you to use. Okay, but normally there are certain questions that you just see when they say differentiate, then you say, okay, for me to differentiate this one using this formula will be very easy for me. So let's see how we can answer our first question. Okay, and our second question is saying find the gradient of the curve y is equal to t to the power 3 minus 1 at the point 1, 0. They want you to find the gradient of the curve, okay, of this curve. All right, so how can we answer question 1? How can we answer question 1? I'm rubbing this part, okay, just to create space. All right, so how can we answer question 1? How can we answer question 1? So under question 1, this is the function they want you to differentiate. So how can we answer it? So I say dy dx, meaning we are differentiating y with respect to x. Okay, we are differentiating y with respect to x. Now if you remember, under lesson 1 we did say that if you are differentiating a constant value, this is a constant value, so it's a 0. Okay, it's a 0, this constant value, plus 5x. The coefficient of x is 5. Okay, then the power of x is a 1. So remember what we are doing in lesson 1? We are saying the coefficient of x, which is 1, times the power of x, which is 1, times the coefficient of x, which is 5. So 1 times 5, you are going to get a 5 there. Then x to the power 1. Remember, here you have x to the power 1. So this x to the power 1, this one will be reduced by a 1. That is the principle of differentiating using the formula. We come to this one, minus the coefficient of x is a negative 2. No wonder I've written a minus there. So the coefficient of x there 2, okay? 2. This 2 will be multiplied with the power of x, which is a 3. So 2 times 3 will give us 6. Then x to the power of 3 minus a 1. Okay? That is the principle there. So I do hope that you have followed what you have done. Just to go through, we are differentiating. This is a constant to give you 0. 5x raised to the power of 1. The coefficient of x is 5. The power of x is 1. 1 times 5, it's 5. Then this 1, this power 1 will be reduced by a 1 because we are differentiating. Okay? So whatever we have done here is what we have done this side. Alright, so how can we complete now this question? Okay, how can we complete it? So we are going to say dy dx equal to, here we remain with 5, okay, then 5x, 1 minus 1, it's a 0. So you're having something like x to the power of 0, okay, x to the power of 0. And any number raised to the power of 0 to give you what? A 1, okay. So this 1 and the 5, this 5 to give you this value 5 here, minus 6x, then 3 minus 1 to give you a 2. This is our answer. So we have differentiated, or we have answered the first question where they told you to differentiate the particular function. Alright, so if you are behind, feel free to leave any comment or any contribution. You leave the comment in the comment section. I'll be able to respond to you. Now let's look at question 2. We've come to question 2. Question 2 reads, find the gradient of the curve. Okay? Find the gradient of the curve. I'm sure you're able to see question 2 clearly. Find the gradient of the curve. Y is equal to t raised to the power of 3 minus 1 at the point 1, 0. Okay? At the point 1, 0. So they want you to find the gradient. So remember, in the first lesson I did say dy dx, this is the gradient. Okay? We say dy dx, this is the gradient. Okay? Dy dx, this is the gradient of this is the gradient. Now here they want you to find the gradient. Okay? The value of the gradient. This one that we have come up with in the first question, this is the gradient function. Okay, as you can see. Now they are telling you find the gradient of the curve for this curve at the point 1, 0. So before we answer, these are coordinates. So this is x, this is y. I hope we know that now. So how can we find the gradient of this curve? Alright, so allow me to erase. Okay, we erase like this. Alright, so from here, remember we are answering question 2. We are answering question 2. Alright, so this is the question that we are answering. So what you do in order for you to find the gradient of this curve, so you write the curve that you are being given, which is y is equal to t raised to the power of 3 minus 1. So the first thing, differentiate this function. Okay, differentiate this function. So when you differentiate this function, remember you have a y and a t. So you are differentiating y with respect to t. Okay, so you are not going to say you are going to say dy, but under dx they are not going to say dx. You are going to say dt because you are differentiating y with respect to t. So you say dy dt. Okay, I'm differentiating y with respect to t equal to, so the coefficient of this t, it's 1. Then the power of this t is the 3. 3 times the 1, you get 3t. So you know that this 3 will be reduced by 1. You're going to have a squared there. Okay? Then for this minus 1, remember this is a constant value. It doesn't have a letter. And I've said if you're differentiating any constant value, it's a 0. Okay? So this would be minus 0. Now I'm not going to write minus 0 there. Okay? We understand what we are dealing with. So from there, this is the gradient function. Now they have said find the gradient. They want you to find the value, not this gradient function that you have come up with. Okay? So I do hope that it's clear. Okay, so how can we find now this gradient function? So what you are going to do is you're going to say dy dx, sorry, I've said dx dt equal to 3. Now here t squared, you say open bracket. So you have been given the coordinates at the point 1, 0. So the first coordinate here, we understand that is for x. Okay, so since we are dealing with letter t, we are given a letter t there. So this letter t will be presented by this value 1. Okay, so say 1, okay, squared, we cross like that. So here dy dt equal to, so 1 squared, 1 times 1, you get 1. So 3 times 1, you get what? 3. This is the value of the gradient for this curve. Y is equal to t cubed minus 1. Okay, so we have answered question 2. We are now going to question 3. Okay, we are going to question 3. Alright, so we are now answering question 3. Question 3 reads, find the coordinates of the point on the curve y is equal to 4x plus x squared, where the gradient is 8. So in this question, they just want you to find the coordinates. Okay, they just want you to find the what? The coordinates. of the point on this curve. So the curve we are being given is y is equal to 4x plus x squared. Okay, this is the curve we have been given, where the gradient is what? 8. So in order for you to find the coordinates, first what you are going to do, differentiate this, okay, where we say dy dx equal to, so the coefficient of x is a 4, okay, and the power of x is a 1, so 1 times 4 will get a 4 there, okay. So here this x is having a power of 1, we understand that, so it's going to be reduced by 1, okay, which will be x raised to the power of what? 0. So x raised to the power of 0, it's 1. So for this one, we're having x to the power of 0, which is a 1. 1 times 4 will get this 4. Plus, here we are just differentiating direct, alright? Plus x raised to the power of 2. So the coefficient of x, it's a 1. Okay? 1 times the power of x, which is 2. So 2 times 1 will get a 2. Okay? Now this x, when you say minus a 1 there, we are going to have x there. Okay? So I understand that this x has got a power of 1, which will remain there. 2 minus 1 is a 1. Now we remove it like that. So this dy dx, this is the gradient. Okay? And in the question they have told you that the gradient is what? 8. The gradient is 8. So where there is dy dx, you are going to put 8. So you say 4 plus 2x is equal to 8. So you can see we have an equation here. Find the value of x. Okay? So we are going to say 2x is equal to 8 minus what? 4. The additive inverse of a positive 4 is a negative 4. Even here, we add the same negative 4 there. So here, 2x is equal to 8 minus 4. It's a 4. We want to find the value of x. Divide by 2. Divide by 2. Therefore, x is equal to what? 2. Because 2 here will cancel. 2 here, 1 into 4, it's 2. So 1 into 2 will get a 2 there. So the value of x is equal to 2. Remember, they want you to find the coordinates. And we understand that the coordinates are in the form x, y. So we have found the x coordinate. Now we are remaining with the y coordinate. So in order for you to find the y coordinate, you are just going to get this function, the same curve, which is y equal to 4x plus x squared, okay, where x is equal to 2. So where there is x in this function, you are going to put a 2 there. So y equal to 4, open bracket, we put a 2 there, plus this x is squared, so it's 2 squared, like that. Y equal to 4 times 2, 8 plus 2 to the power 2, meaning 2 times 2 will get a 4. So here y equal to 8 plus 4 will get a what? A 12 there. So x is equal to 2, y is equal to 12. What is our answer now? What is our answer? So they want you to find the coordinates. So just write it now in coordinate form. Okay? Therefore, the value of x is 2, comma, the value of y is a 12. So these are the coordinates. Okay? These are the coordinates. So thank you so much everyone for viewing this content. Okay? If you are stranded somewhere, you are not clear, or you have a contribution, feel free to leave the comment in the comment section. Then I'll be able to reply to your comment. And don't forget to subscribe to my YouTube channel. If you're watching us on Facebook, don't forget to like the page, to share the page, and invite your friends so that they can come and learn with us. Bye bye.